So, hello and welcome to the next video. In this video, I'm going to give so to say, another getting started. In this sense, getting started to use the eval board as an ESC, which is more targeted towards boats and cars. That means also having a reverse function. Um, in the getting started about the toolchain, it ended with using this potentiometer to control the motor speed. And this can also be done via a pulse signal, which is typical for the RC hobby, which goes usually somewhere between 1 millisecond as the lower end, 1.5 millisecond as the neutral, and 2 milliseconds as the maximum. And the eval board here has connectors or solder pads where I connected a device which can also be used as a generator for these signals. Yeah, there is going to assume that you're familiar with the tool chain, so I'm not going to walk over that. The only thing I'm going to point out is in the workbench to deactivate the POTI. This is turned to off, and to use the board as an ESC with set control signal, this has to be turned on. Yeah, so this will play no further role here. What I'm going to do is we're starting off with the out-of-the-box ESC demo project, and then I am applying stashes, which I have in my version control, which in a first step will add a reverse, and in a second step, braking function. So currently the board is flashed with the out-of-the-box demo project. So that means that is defined to have, so to say, it's off at 1 second and 40 milliseconds, and when increasing, this controls the motor speed. So this is, and there isn't more to that to show. So the first two things I thought about: how easy can I adapt the demo firmware to become something which is more suitable for a car. That means that it can run reverse and has a neutral at 1.5 milliseconds. And the major place to go is this ESC file. What a coincidence. And I first tried to find out, also the first thing I tried, how easy is it to reverse the motor? And in general, for these three-phase systems, reversing something is by swapping two phases. And I honestly hope that I don't have to go that deep into the motor driver. So I looked for something which is more simple, and yeah, I'm going to show where that can be done. So I looked for something where speed is applied, and this is the function where this is done. Here the speed is applied, and when looking up the declaration of this function, where is it? Yes, that shows that the desired final speed is a signed integer. So that sort of implies that it is supposed to be also be fed with negative values, which would be something like a reverse. So I simply tried out something like, in general, something like this, and see if the motor reversed. And at first it had the ramp up and then stopped. And the reason for that is that here is the ESC armed case, and this is executing the ramp, and here the value has also to be with an encoding sign. Otherwise, the motor tries to start forward and then wants to turn backwards, which of course doesn't work. So yeah, that has to be kept in mind. And the second thing is the value which holds the input value of the control signal, and that turned out to be simply this one. So the the main part for me to interact currently with the ESC is basically a state machine, a switch case state machine, which has different states, which are listed here. So currently there is the arming, that is when the controller is in neutral and the user applies a signal which indicates to turn. And then it accepts that ESC is armed. Then there is a running, and then there is a stop. So around here are our first targets to try out, and I'm going to apply the first stash now. Yeah, that now, and we're seeing now that there are now differences, and we're going to take a look what these differences are. Also, I made these before, and I just saved them as stashes, and now we're looking what the changes are. So there are also some other files of interest than just the ESC file. So these values, also this is a part which copies some values to an instance of an should be a structure, and there is not that much to say. We're going to see more what these values are in another file, which is here the parameters. And so these values, these changes here are basically creating the neutral at 1,1500 milliseconds, and then the active area between 1,520 and 2,000 for forward, and 1,480 and 1,000 for backwards, and defines a neutral space of 20 milliseconds. How applicable that is a different question. So this is more about tipping the toe into the water. Yeah, so now to the interesting part, which is, this is a bit of clicking. So we're going first to the ESC header file. And so what we see here is these are the added steps for reverse, which are pretty much counterparts of the forward versions. So, and that's the strategy I applied for most of these values, that I tried a bit around for which values I'm going to need the reverse version, so to say. And here is also a magic thing, which is this, that the arming counter now is also an assigned instead of an unsigned value. We're going to see in the source file why that is. So now the really interesting thing. We're going to diff again. So these are some values which are used in the process later, not that much to say to it. And so this is basically the neutral, also when the ESC is in neutral. And since we can now also go reverse, also arming is the process when the ESC decides if it goes out of neutral into one or the other direction. And so there is not only a forward now, but also a reverse. And there is this arming counter. And now it can be armed in two directions, and that's why I made it a signed value, where a positive value represents a successful arming in one direction, and a threshold of a negative value that's visible here represents the arming into the negative direction. Then further things, here's not really something changed, that was only something that happened while playing around. And yeah, this case ESC wait for stop was something which was, also this line was effectively also in the cases for when running forward and backward, and I found it more explicit to give it its own state. That's the only thing. Then here is also these cases now, which are now called ESC armed reverse, and there's some ESC negative run, are basically counterparts of the cases for running forward. So I mostly only adapted a few calculations or changed some pre-signs for the signed value, especially this one. Yeah, and that's pretty much it. The rest of the logic, I didn't touch it. My philosophy here was not adapting more than I actually need to understand, get a feeling for the uh, fundamentals. So that means enough talking, and we're flashing now this feature that it also can run in reverse. And I then quickly have to set the impulse also to neutral. Okay, it's done flashing, and now the control is in neutral, 1500 milliseconds. And when going in one direction, you probably can see it on the bell. The motor starts in one direction. And when clicking in the other way, the motor starts in the other direction. So yeah, now we have a reverse. Also we have a forward and a reverse. I'm going to commit this for then going to the next stage. I'm going to call it add reverse. Okay, that's done. Now I'm coming to the next part, which is also providing a braking function. Also that means when like driving forward and pulling the stick backwards, that there is an effect of braking, also that it slows down and somehow proportional to the how far the stick is pushed back. So, and for that I also have a stash saved, which I'm going to apply. So here we are. Now we're going to the IDE again and build the project. Yeah. And this is probably not so easy to demonstrate. I would probably have to have a rotating mass here to show the braking effect. Yeah. So in the source code, what has changed there? So we're going again all down the rabbit hole. Yeah, I'm not going to the esc.har file. I basically added some more. Yeah, okay, we can do that. Why not, for the sake of completeness? Yeah, so there's basically new some more states, and that's it. So the next thing, the source, there's a bit more magic happening. So one thing, of course, is when running forward or backward, in this case ESC positive run, when the input control signal goes into a direction to be not, in this case, forward anymore, it doesn't go to ESC stop directly, rather than to this new state, break while forward, and that implies there's also one for break while backwards. Then here is also another change, and what this is doing, this is the part, also here the new calculated speed is used, and if this speed is when the new speed is bigger than the current speed, it is applied directly, and when it is smaller, then here the current average, also the speed the motor is currently running at, is applied with 90% instead of the new calculated speed. The idea behind that is, since the FOC tries to target a provided RPM, slowing it down can feel a bit abrupt. So that is the idea of using the current RPM and provide that with 90%. So this slowdown is not that abrupt. That feels a bit unintuitive. Yeah, then yes, basically the same logic for break while, this is also the new thing, break while forward. And here are also some calculations. So and so the first part is the idea behind this first part of the if clause is, when the motor is slowing down, to have something to decide when going into the wait for stop state. And I simply defined it now for just trying out when the current RPM, which is red here, is smaller or equal than the minimum value of plus 10%. And if this is not the case, then we are still in the process of braking. And then here, the calculated speed is used. Here the calculated speed is used to determine a speed decrement, which is decremented from the speed the motor is currently running at, and then applied as the new target speed. And this speed decreasing value goes by how far the stick is pulled back. And and here is basically mirrored the same idea for when going backwards. So I'm not going to rephrase that all now, rather than let's see if we can see the result. Let's go to okay, so without a rotating mass, it's not really visible. What is it doing now? I have to figure something out. Yeah, maybe the neutral part is a bit too narrow. I'm going to find that out. Yeah. All right, that's so much for it.